Hello, I'll be doing a short session on trigonometric ratios tonight. It's actually quite late, so I'll make it short, probably try to keep it under 15 minutes. The idea is to give a small introduction on the trigonometric ratios for 2-unit students. In 2 units, you have 3 main ratios: sine, cosine, tan, and then derived ratios cosec, sec, and cot. So the main things you need to remember is sine, cosine, and tan. So if you have a triangle, right angle triangle, and you have an angle called theta, if you write, and you have opposite, adjacent, hypotenuse. So if you write sine theta, that will be opposite over hypotenuse. Cos theta for this angle would be adjacent over hypotenuse. Tan theta would be opposite over adjacent. So which is very simple. I think you learn it from year 10, 11, and then you keep continuing it. Okay. Now in 2 units exams, you have MCQs and in the section 2 questions. Sometimes they will test you in MCQs for questions like, say, they'll ask you how to find sine 150. Then you need to know that just out of your head, you need to be able to find it. To do that, we have a couple of main, you can't use a calculator. So you have to do it somehow using the known values. So that's a simple question they normally put in the MCQ. So they can ask you to derive a graph of sine graph, or just they'll give you a sine equation like sine 2 pi plus pi over, sine theta plus pi over 3, 2 sine theta plus pi over 3. Then they ask you which, they'll give you 5 graphs and ask you to pick the right graph. Things like that they will ask you in the MCQs. Okay, let's put, let me delete this. We'll come to the main values of sines, so that you need to remember. So we have few main angles. This is pi by 6 is 30 in degrees. Pi by 4 is 45 in degrees, so this is radians. Then you have pi by 3, which is 16 degrees. Then you have pi by 2, which is 19 degrees. Okay, you need to remember the sine, cosine, tan values for each of these angles. Sine, cosine, tan. So this has to be stamped in your head, not on a paper, in your head. So you need to remember these values. Sine 0 would be 0, sine 30 would be half, 1 over root 2, root 3 over 2, 1. And cosine would be reverse of it. So you need to be fast when you remember this. It only comes if you practice it. So this is 0, 1 over root 3, 1, root 3, and infinity. So this is important, very important to remember. Okay, because you will use this to find other angle, sine, cosine, tan values of other angles. We'll do one example. Before going to that, we see that here you might have already figured it out that this sine 60 is equal to cos 60, and you can see sine 30 equals to cos 60, sine 60 equals to cos 30, so sine 45 equals to sine cos 45. So why does that happen? If you think about it a little bit, maybe I'll erase this, or maybe on the side, let's delete that. Okay, on the side I'm going to write, why does that happen? If you look at a right angle triangle, if you think of sine 30, say this is 30, they are saying it's half, right? So that means your opposite leg would be 1 and this would be 2, because that's why you get sine 30 equals opposite of hypotenuse. Now if you use the Pythagoras theorem, then you can work out this leg to be 2 squared minus 1 squared square root, which is root 3. Now if you write cos 30 for this, that would be your adjacent root 3 over hypotenuse 2. Right? Now if this is 30 degrees and this should be 60 degrees, right? Because it's a triangle. So you have 30, 90, 120 and the remainder should be 60. So if you write down now cos 60 for that angle, which is cos 60, would be adjacent, which is adjacent would be 1 over hypotenuse, which is 2. So you will see now sine 30 and cos 60 is equal, because the way the angles are related. Basically it's just the two angles in the right angle triangle. So there's no surprise there. You might have already figured that out, but it's just to make you thorough in this area. It's important to get your basics right. Okay. Now we know the main values of sine, cosine, tan for the major angles. Okay, right. Let me clear this up. Okay, now what are we going to try now is we'll probably try a question, or maybe before that we'll write down a couple of major rules that you need to know. So okay, let me get the black pen. Sine 90 minus theta equals cos theta. You need to remember this. Not necessarily, but we'll remember this when you go through this lesson. Cos 90 minus theta is sine theta. Tan 90 minus theta is cot theta. So that's a rule. The rule in the sense, if you have an angle theta associated with 90, your trig ratio sine becomes cos, and this angle comes here. Cos becomes sine, theta comes here. It's only when you are associated with 90. Remember that. Only when you associate it with 90. Tan becomes cot, theta comes here. So this is something even the smartest students just mix it up sometimes, because it's not a hard thing, but sometimes you just get confused. So remember, it's only when you have 90. So remember the rule. Sine 90 minus theta, sine becomes cos, theta comes as it is, cos becomes sine, theta comes as it is, tan becomes cot, theta comes as it is. That's the three rules that you need to remember. Okay, now there are three more, but when you have sine with 180 minus theta, so see here, this one is not 90 now, 180 now. Okay, so when you have it with 180 minus theta, the rule is sine remains as it is, sine theta comes there. I'll stop on that rule. Maybe I'll do the next rule as well. Cos 180 minus theta, cos becomes cos, theta is there but it is negative cos theta. I'll tell you why that happens. Then you have tan 180 minus theta becomes minus tan theta. Now important thing to remember here is whenever you have 90, your trig ratio changed. Sine became cos, cos became sine, tan became cot. But whenever you have 180, sine didn't change. Cos stayed as cos, tan stayed as tan. But there was change to the positive or negative value of it, that we'll deal with it later. But important to remember is that when you associate with 180, no change to the trig ratio. 90, when you associate with 90, the trig ratio changes. Okay, now to explain it in further detail, let me go into the quadrants. So I suppose you are familiar with the quadrants. The quadrants, normally we have, starting from 0 angle, you go to 90 degrees, then you come to 180 degrees, then you come to 270 degrees, then you come back to 360 degrees. So 30 or 360 doesn't matter, you are at the same point. So after 360, whatever the revolution you do, you'll still be same as, so 90 would be same as 450, and you come back here, 450 plus 90, 520 should be same as 180. So it doesn't matter, so you need to remember only 0, 90, 180, 270. Okay, let me just clear that up. That's some extra information which you might find helpful. Okay, so I'll go back to the quadrants. 0, 90, 180, 270. So this is your quadrant 1, this is the quadrant 2. So quadrant 1 is from 0 to 90, quadrant 2 is 90 to 180, quadrant 3 is 180 to 270, quadrant 4 is 270 to back to 360 or 0. Now each of these quadrants have positive, negative signs for sine, cosine and tan. Most of you might remember this in different ways, but normally the way I remember is ASTC, which is a dull way to remember probably. Let me clear this up. Okay. A stand for all, S sine, T tan, C cos. So in the first quadrant, any trig ratio is sine, cosine or tan is positive. Only sine is positive in this second quadrant, because that means if you have an angle, say 150, which is in the quadrant 90 to 180, sine 150, if you look at sine 150, the value of that would be a positive value. That's what it means. Tan in this quadrant would be a positive value. Cos in this, any angle in this quadrant would be a positive value only for cos. So cos value, cos, say here we have 300 degrees, which is coming all the way here. So cos 300, we know for sure that will be a positive value. The value of it we don't know yet, but that for sure would be a positive value. Okay, now having said these things, I can now explain why this okay, having said these things, I can now explain why did we get cos to be negative and tan to be negative here. Now we have the quadrants ASTC. Now when I said 180, so I'm looking at these ratios inside the green box. When you look at sine 180 minus theta, it's talking about, so 180 is here and then minus theta. So they are talking about a theta angle associated with 180. So this part is 180 minus theta. So we know for sure 180 minus theta has to be smaller than 180. So if it stays in the second quadrant, because we wouldn't say 180 minus theta if theta is, so when the theta is between 0 and 90, it has to be in the second quadrant, and only sine is positive here. So that's why when you have sine 180 minus theta, you have a positive value, and then you just write sine theta. When you have cosine 180 minus theta, what happens is cos is in this quadrant, cos is negative, and that's why you need to put negative value, and then you just put cos theta, because when you associate with 180, your ratio doesn't change, you keep it as it is. And then when you have tan 180 minus theta, then you still have to put negative, because tan is negative in this quadrant. That's why you put negative, and then you put tan theta. So I hope that clears up why we have negatives. So you can logically remember why these two ratios get negatives in the second quadrant. Okay, now that part is clear. So you have to remember this equations. It's not hard to remember, it just has to be on your photographic memory or something. We'll do more questions and it'll get easier when you do it. Okay, let me clear this page. Okay, now cleared. Okay, now let's say we have a question asking in an MCQ, find sine 150. Okay, so if they ask you sine 150, you can't just say okay what it is. You don't know. At the moment you don't know. What you need to do is try to find 150. So 150 should be in the quadrant 2. Right? Oh, it's not a straight angle actually. I see it like straight line, but anyway, that's 150. So that's 30, right? So you're trying to find sine 150, which is the question. Now you can write sine 150 as sine, associate this 150 with 180. So 150 would be 180 minus 30. Now remember the rule, sine, okay, I'll write the rule in red. Remember the rule, sine 180 minus theta equals sine theta. Okay, so using that rule, we can write here positive, because it's in the quadrant 2, because sine is positive. Sine theta, I can't write theta, I have to write 30. Now sine 30 is half from the previous table, so sine 150 is equal to half, so that's your answer. Okay, now let's say we have to find, we'll do another question, I'll do it here, cos 150. Same thing, cos 150 equals to cos 180 minus 30. Okay, now the rule here is cos 180 minus theta is cos theta, but the sign of it would be negative because it's in the second quadrant, cos is negative. So if we follow the rule, negative cos 30. So cos 30 is root 3 over 2, and that's negative. So now that's cos 150. Okay, now that's That's done. So we found the answer of course 150. So that's how you use the rule if you have to find an angle which is in the second quadrant. Now what you need to remember basically is you can extend this rule to the third quadrant or fourth quadrant, which means either you are here or here, doesn't matter, you can do it. Only thing you need to remember is when you associate any angle with 180, say sine, even if you have sine 180 plus theta, which means you will be here, right? 180 here plus theta means you are here. If theta is between 0 to 90, then you will have HSC, then your sine would be negative sine theta. So that's the rule. So you get the sine from the quadrant, then if it's associated 180, you write sine theta, basically the same trig ratio. Okay, let's do a question. Let me clear this up. So let's say we have to find sine 210. Now sine 210 would be sine, so 210, I'll have to write it, so I'll clear this up. Two 210, so that's 180, and then you have to have 30, 180, so that whole angle would be 210. So sine 210 is equal to sine 180 plus 30. Now what's the rule here? First check the positive or negative sign of the quadrant. So ASTC, so it's only tan positive, but this is a sine, so it's negative. Then I can write sine the angle sine 30. Because sine 30 is half, so the answer would be sine 210 would be minus half. Most often they don't give you 210 like that, they will give it to you in radians, so which would be 210 is equal to pi plus pi over 6, which is 7 pi over 6. So they will ask you what is the value of sine 7 pi over 6. So one way to do that is you can just calculate yourself and get the angle. Okay, you can do it using the calculator as well if you have a calculator, but for MCQs it's easy to remember. Okay, now what I want to explain here is whenever you associate with 180, just keep it the trig ratio as it is, just get the sign. We'll do one more example. Let's say you need to find cos. What I'm going to find 4 pi over 3, value of it. What's the answer? We don't know. How do we find it? Okay, what is cos 4 pi over 3? So it's easy to get it in degrees. So pi is 180, so 4 pi over 3 would be 4 times 180 over 3, 60 to 40 degrees. Now that means you are in the third quadrant. So cos 240 would be 180 plus 60. This would be 60. Cos 180 plus 60. Now this ASTC sign of it would be basically sign in the sense positive or negative value of it would be negative because cos is negative. Then cos 60 would be half minus half, so cos 4 pi over 3 would be minus half. Okay, so that's couple of questions, examples, the very basic ones. to get you the basic values of this trigonometric ratio. Suddenly my heater came on. I don't know why. Heater just turned on by itself, so that's why you ask if you're hearing any humming sound, that's from the heater. Okay, let's do one example question. I think that's enough for that's enough to clear it up. Maybe I'll just give one more example. So whenever you associate with 180, those are the rules. But what if you have a question with, say, let's find 150 in two ways. So one sine 150, the way you found before was 180 minus 30. So sine 180 minus 30, sine is positive because it's in the first sine quadrant, sine 30, and that's plus half. That's good, that's the right answer. Now you can do the same with associating this with 90 degrees. So 150 is 90 plus 60, right? Now remember the rule. Remember this rule: cos 90 minus theta is sine theta. So what I told you at that moment was, whenever you associate with 90, cos becomes sine. So I can use similar derivative of that rule. I can derive something from out of that rule. I can write this as cos 90 plus 60, because cos becomes sine when it associates with 90, and then you have 90 plus 60. So here, when you have 90 plus 60, you have cos 90 plus 60 sine of, oh sorry, my bad. Why did I put cos here? Sine 90 by sine 150 is sine 90 plus 60. So the rule we should be using is sine 90 minus theta equals cos theta. That's the rule. But if you have it sine 90 plus theta, so I am deriving a rule from it. If it's 90 plus, sine becomes cos theta. The sine of it would be the sine of, so sine is here, so it's positive. Now here 90 plus 60 becomes plus, because sine is in the quadrant, so 90 plus 60 is here, and then sine becomes cos from this rule, then 60 is there, so the answer would be plus cos 60, which is also half. So you'll have the same answer either way you do it. So you can associate with 90 or associate with 180. I usually try to do it with 180 because it's straightforward, there's no sign changes. That's extra part, so if you don't understand it, you don't have to. Just for clarification, that you can use it, you can either associate with 90 or 180. Okay, it's getting too long now, so I'll just jump into the question. Okay, let's say you have a question like that. So they give you sine x equals 0.2 and ask you to find sine pi minus 6. So how do you find it? Simple. So we are in the second quadrant, because it's, if x is between 0 to 90, so that's pi, that's x, so that's sine ASTC. So sine pi minus becomes positive because it's in the first quadrant, positive sine x. The answer would be 0.2 because sine x is 0.2. Okay, let's do the part 2 of that, sine 2 pi minus 6. Now that's new because that's 2 pi, right? 2 pi minus x is here. So that's in HSC, fourth quadrant. So it's negative because sine is negative in this fourth quadrant, right? And then x, sine becomes sine x. So whenever you associate with either 180 or 360 or 0, doesn't matter. Whenever you associate with this axis, sine stays as sine, cos stays as cos, tan stays as tan. Okay, so that's wait, okay, that's minus 0.2 then. That's your answer, right? Okay, now let me clear that things up again and let's do it even clears up the question. Now let's do this cos pi over 2 minus x. Now that's interesting because we are using a rule that we already know. That's 90 minus x, right? This is 90. So if I draw this in a quadrant, I am somewhere here. That's pi by 2 minus x. So when you have cos 90, it becomes, the sign of this would be all, that means positive, and then cos 90 becomes sine x, and sine x is 0.2 plus 0.2. That's your answer. Okay, question 5. Sine pi by pi plus x. Again, in the quadrants, that's pi and x, so that should be pi plus x, which is in HSC, so it's negative because it's negative for sine x, which gives me minus 0.2. So that's how we normally do questions like that. I think that clears it up. I don't want to do more questions because it's already 12 o'clock in the night and I'm feeling sleepy. I might sleep halfway in the next couple of questions, so I don't want to do it. But if you have more questions to get to trigonometry or any other related topics, doesn't matter 2 units, 3 units or 4 units, you can write to me. If I have time, I'll try to do a video on it. If you like the videos, subscribe to the YouTube channel and also share with your colleagues. And we have a Twitter feed, also you can subscribe to that as well. Okay, I'll see you in next video soon, hopefully. Okay, thank you.